Okay, just to let you know, yesterday there are a couple of students in my office checking for, say, the connection to homework 2, part 1, I believe, is not is connection reset. So I actually checked after I got home. I realized that the server is down. So that's why it's nothing to do with VPN, the network. So it's just because the server has some situation it didn't anticipate and it actually crashed. So just from now on, I'll let you know that this is always a major engineering issue, is try to keep any service up 24/7. So that's why later, as a computer programmer or computer engineer, we always try to see how do we make the service 24/7. Just like I think a few days ago, a couple weeks ago, that Facebook has a major service break for about 6 hours. That's really unusual for a company, a service like a Facebook. On the other hand, with the amount of activity they're supporting, it's quite impressive that they actually did let that happen very often. All right. So so the other message to you is that in the future, if you have some issue, just notify me. So I will actually check. In fact, I probably will not talk about this today, but I did have a program that automatically check every single homework server, whether they're up and down, and post the result on the web. So you can actually go to that website to actually see whether that service is up and down. I will announce that where is that the server service. Okay, so today we're going to so up to this point we handle all the issue for the single inheritance, the basic inheritance issue. So there are 2 more topics I'm going to cover for the next few lectures. In fact, there are 3. The first topic is called virtual function, which I'm going to talk about today. And the next topic is multiple inheritance and virtual inheritance. That's the other topic I'm going to talk about. But then there is another topic which is related to homework 3. It's called shadow objects. So essentially what I'm going to do is I'm going to first talk about virtual function, which involve both chapter 13 and chapter 14. And then we also will look at some of the pointer, because virtual function, in fact, is a pointer to function instead of pointer to a particular data item. And so we will actually talk about chapter 6 as well. So just let you know that this is the flow of, if you're curious about which chapter of the textbook we're looking at, that's actually chapter 13, 14, and chapter 6. And the idea of shadow object is not covered by your textbook. So you have to follow me with slides and lecture. But shadow object is actually a very powerful concept for you to do object programming. When you want to address, you want to write a program to interact with a huge number of objects, while some of the objects are distributed around the world. So instead of for you to worry about the locality, where they are, what's their status, you actually have a local shadow. So you're actually interacting with a lot of shadow. And those shadow is like your agent will actually handle the connection or wrapper to the real object somewhere in the world. Okay, so that's the flow we're going to talk about. All right, so we have this inheritance hierarchy. In fact, it's still a single inheritance is a relationship that from the base class and derived class. And the thing is that now I actually define a member function called foo. So now I'm actually showing you the difference between the regular member function in the inheritance and what we call virtual member function in the inheritance. So let me first introduce you the keyword. If you add in your declaration of the class A virtual, then that particular member function is what we call virtual function. This is just syntax. I haven't tell you what does that mean, what's going to be a difference. But let me just show you an example of a virtual function by looking at your, say, homework assignment number 3. Let me make this bigger. This one, okay, yeah, that's good. Okay, so you're kind of familiar with this file called person.h for your homework assignment number 2, but I want to show you that there is a main difference in the class person for homework assignment number 3 going to be somewhat extended from your homework assignment number 2. So of course you can see that now the person itself is inherit something from called core. So I have another new class called core, which is basically a base class for everybody else. But remember, you have to do this operator equal in the homework assignment number 2. And that operator equal, if you remember, doesn't have this keyword virtual in front of that. So now we have a virtual in front of that. So that's just syntactically, how do I declare a member function is a virtual member function. Okay, that's the only thing, that keyword. I haven't told you at all about what does that mean. Okay, but now you know syntactically that this is how do you actually make a function become a virtual function. All right, so now let's actually go back to understand the concept. Okay, so if it's a real regular function, so assuming this is not virtual, member function is just a regular member function foo. So I have a base class and derived class, both of them have foo. So the question to you is this. Now I'm looking at my syntax. So I create a object. The first line is create a object which is based on the base class. So it's my base, that's a class name, obj1. So basically that's a whatever constructor I'm going to call. And then I create object 2, which is using the child. Okay, so I create one based on the base and one based on the derived. And then I actually call both version of the foo. So that's why I call obj1.foo, obj2.foo. And now you have been asking about the casting. Now I'm doing a little bit trick called casting. I actually casting object 2 to my base. So essentially, I'm casting an object I created based on the derived class and transform that to the base class. And then I call them foo. So I have a 3 statement here. So my question to you is that now this is nothing to do with virtual function yet. It's just a regular C++ single inheritance. Under this case, which version of the function that each of the 3 statements is going to call? There are 2 versions of foo, right? One is base and one is the derived. So let me actually ask you a question. How about the first one? The first line. When I say first line is this line. Which one? Base or derived? Base, good. How about this one? Derived, right? How about this one? The third one is a little bit tricky. It's still base, okay? Because you're casting it to be a base. So this is the idea about casting. When you cast in a inheritance hierarchy, whatever you cast, that object will behave exactly as the result of the casting. So that's why that third line, after that green casting, that the whole object pointer became the pointer to an object that's really base, that pure base. In fact, he forgot he is a derived object. He will think he's only a base. And therefore, because object 2 at that moment with that casting believe that he is a base, then when you actually ask them to do a foo, it's going to be a base. So essentially, this learns one thing is that how you use casting to change the behavior. But the other thing is more important for you to understand is that which function I'm going to call is really depending on the type after all the casting before you really make the call. It's really looking at that, it's just simple class type or object type determine its behavior. Yes, please. Sorry, can you speak louder? Here, this is the result, looks like this. So the first line is going to call the parent version of the foo, and the third one also will go to that. The second one will go to base. That makes sense, right? That's conceptually you would have expected about the behavior. If you know that which function is going to call is purely determined by the data type of that object instance right before you call that function. And the compiler will know that. I mean, that's essentially what compiler can decide, right? The compiler, when they look at it, think about if you're writing something for compiler. I don't know, probably we never include that in the curriculum, but writing a compiler, it gives you a lot of perspective about what is programming language restriction and how they think. Okay, so you think about compiler. The compiler, when I decide which function to call, that's called code generation. The compiler needs to decide how to jump to control the particular piece of code. How do I determine that? I actually look at the OBJ1 and then try to find out what's the data type. And based on that data type and the compiler time, I can decide which function I should call. Okay, so learn, know a little bit, think about how compiler can decide will help you a lot to understand virtual function. Because in virtual function, you will realize that compiler lost that capability. I mean, the idea of virtual function is hard, is because compiler cannot even decide. I will show you what virtual function is, maybe in the contract. But I want to emphasize at this moment, the compiler can actually determine for you about which one. Okay? Any question? Okay, so now we're looking at this one. We're looking at this one. If we define this as a virtual function, still the same thing. Okay, exactly the same piece of code, but still 3 lines. Now I'm actually going to tell you what it looks like. The result is like this. So if it's a base, if it's object 1, it still actually go to the foo, object 1. But if you do object 2, of course, it's still, the first 2 lines will be the same. Okay, if it's a virtual or not virtual, the first 2 lines is going to be the same. But the difference is the 3rd line. The 3rd line is you actually casting it. If you're casting it to an object that's to its base class, it doesn't change its behavior. It actually still calls the version that's originally associated. Let me actually tell you what the virtual function really is. The virtual function means that regardless how you cast it, regardless how you change the type of the object, that whenever you make a call, I'm going to invoke the particular function associated with this object at the time this object was created. So if an object was created as a derived, then no matter how you manipulate the pointer, manipulate the reference, it will still actually go back to its original intended behavior. So that's the virtual function. Okay, I'll just first tell you the definition and tell you the simplest case. Virtual function, then I will go a little bit deeper after this. Okay, any question? Yes.
Like if you declare like a base class, like
So I try to understand your question. You're saying that when you create an object, it must associate with some type, right? And you might be able to copy this object to the other one. For example, if this is a derived class, but you're casting with to a base class, and then you do copy constructor to another base class. At that moment, we consider that new object you just create. At created time, it was a base class. Yeah, but that's yeah, good question. Okay, so let me actually summarize what I just said. This is the main difference between member function and virtual function. The member function is that we define how do I define which function is based on the reference class type of the object and the time of the call. Okay, so this is a regular function and the time when you make the call. What data type or what class type you are. That will determine which function I'm going to call. But in virtual function is essentially determined at the time, the reference of the object at the time of the creation of the object. That's what I'm saying. Okay. If you understand this, now I want you to think about one question. Why do I do this? I just want to make sure that this is a very important point for you to understand. I want you to discuss with whoever sit near you, 2 students, 3 students, you discuss together. Why did I say that the compiler has trouble to actually to support the virtual function and the compiler time? Why this one, in contrast to this one, at the time of the call, the compiler has no problem to do that. The compiler actually don't know. This one. The compiler actually don't necessarily know that what class that particular reference is. So talk to your neighbor for about, I give you 2 minutes, okay, just discuss a little bit, and hopefully some of you will come up with some answer to share with the rest of the class. Okay, go ahead. Try to find your friends around you. Okay, 30 seconds. Okay, any student like to share your discussion regarding the question I just asked about the determination at compiler time about which function to call? Yeah. I think that's correct. To make things a little bit more complicated, you might did the casting in some other function. So it could be that I actually casting at the first level of the function call, and I pass in as a base class, as a parameter call by reference. That's why it's call by reference. It's call by value. Anytime you do call by value, the virtual function mechanism is gone because you're doing a copy constructor. Then at the time you do copy constructor is no longer a virtual function type associated. So assuming you do call by reference, and then you actually pass the reference all the way to 13 level of function call. At the D of the 13 level, that compiler actually don't know the reference I'm dealing with is actually from this particular derived class or the other derived class, because I have so many. So let me give you an example that in this room, we have member from student of UC Davis, maybe staff from UC Davis, and teacher from UC Davis. But our base class is what we call community member. Remember that class hierarchy. So assuming we all got casted to a community member object, and we give this whatever call by reference to some NU conference room. So we all go there, we try to present ourselves about our idea. So if it's a regular function, then if there is a one particular function, then we will all behave exactly the same because we're all community members. But if I implement this as a virtual function, then when we're in MU, we got called. We're going to behave different. Some of us are students, they will be representing the student's best interests. Some of them representing staff is going to talk about from staff's perspective. And the professor will just be silent and just watching as we always do of the classroom. Okay, just joking. Okay, so you can see that this is the mechanism that even though as if looks like everybody is the same, when I actually invoke a function, they are going to behave differently. So this is called polymorphism. So that's why the word polymorphism means that it looks like it's the same thing, but they will behave differently. And C++ implementation is virtual function depending on what is your original class membership at the time of creation. Right. All right, so I talk about this concept. The other thing I said, compiler cannot determine. The compiler cannot determine which function to call at compiler time because it's actually pretty, how do I say that? Because you don't know what is that original membership at the compiler time because I only look at this function. I actually didn't even know some of the library call that's actually already been compiled in the object format. So I lost a lot of information in the compiler when I do separate compilation and try to link together. And so basically, I cannot even know that whether this is possible in the compiler time. Okay, so now I want to pose you another question. Then how do I, or maybe C++ did this? How can they do this? If the compiler didn't know, how do I know to make a call? So obviously I'm talking about runtime. This decision we have to do in runtime instead of compiler time. In runtime, you have to decide what is a membership. To know this is probably the hardest concept, as hard as pointer, but this one actually is more fun because it really extended your knowledge about ecs36b to another level. I mean, how do I actually know? Anybody want to give a guess? Yeah. What? Something similar to that. But at the time of creation, because let me ask you the first question: when do I actually know what is the original class that this object is actually created? At the creation time, right? That's the only time. If the compiler cannot derive the knowledge, then the only time I can actually do something is at the creation time. And similar like what you said, you might be able to add something, say, what is the original class? So you use that information to determine at runtime which version of this to run. This is, by the way, this is something most programmer doesn't need to care about, but I think it's good for you to understand this level of knowledge. So essentially, we use the concept for function pointer. We use this for function pointer. So essentially, if it's a regular function, the compiler already linked your code to call the right version of code. But let's do a recording here. Is that when you know that this is the virtual function, and you know this is supposed to link to something else, what we do is that we don't let compilers directly link us to the code, but instead, I actually write an indirect call. So indirect is a pointer. I actually put it in the place where the compiler usually will directly call. I put a pointer at the time it was created. That pointer is the real function I like the virtual function to be called. So that's called function pointer. So essentially, I put a function pointer as an address in my class, in my object, for every single object I created. For homework 4, you actually will see where they are, hidden in your code. So essentially, with virtual function, you will realize your memory is not just hosting for those member variables that you declare, but there are a few extra bytes they will be reserving for virtual function pointer. So if you mess up, you might actually mess up pretty big because you actually make the runtime unable to actually make the right call. So that's one thing. I have to record some information. It's called function pointer at the time the object was created. The second thing you need to do is that at the time when that call is really being made, the compiler knows that this is a virtual function. So the compiler link the code to treat that whatever pointer value is as a function pointer, and then indirectly call that function pointer. So virtual function number 1, it takes more memory space, as I mentioned, because you need to have a table to remember each of the virtual call, where that really is. The second thing is that the performance of virtual function every call is more expensive because usually the compiler just directly call it. I can do compiler optimization, I can do a lot of things. But with virtual function, you're going to first retrieve that pointer, and then you have to make that pointer become a function and then call it. So there is a few extra steps that you need to do in order to make that call. That's how virtual function is really implemented. I'm going to just tell you the concept, but later you will be able to see the detail when you actually see the memory layout. When we talk about both virtual function and multiple inheritance. Multiple inheritance is memory layout, it's pretty messy as well. Okay, sometimes it's good for programmers to know this level when you want to really understand to the bits and bytes in your memory what they're doing, not just looking at higher level. That's unfortunately something C programmer has to do. Okay, any question at this moment? This is my first introduction to virtual function. Okay, so now I'm going to, assuming you know virtual function, you know, at least I think this example is very simple, but this example captures the most important meaning of the virtual function. That's the difference. Regardless how you're casting it, you will still go to the same place. if you just want to use virtual function, it's not that hard. It's just the harder part is trying to understand what virtual function is really implemented and where it messed up your memory layout of your object. That part is actually not tricky. But unless you're doing some kind of system programming, sometimes you might not need to use that part. Okay, with that, I'm going to spend my last 12 minutes here to talk about shadow object. So let me first clarify, shadow object is the very important concept for a lot of the homework assignment from now on. And it's not covered by the textbook, so you have to pay attention to me and the example that how it works. So it's actually just say this. So essentially, what shadow object really is a utilization of virtual function to be able to implement something in a distributed world for object-oriented programming. So what is the shadow object looks like? The shadow object actually looks like this, assuming this is the real object. The real object is actually, object represent a person or the object represent a sensor, for example, monitoring the air quality of things. That's a sensor. So typically an object from now on is not necessary the object actually only sit on your computer or sit on CSIF. So essentially an object could be anywhere in the whole world. And then I like to interact with that object remotely. So there are obviously two ways to do it. One way is actually you build a database to track each of the objects where they are. So every time you actually realize that, okay, this is an object in Davis, this is an object in France, near a particular location in Paris. And the thing is that when you try to retrieve the information, interact with this object, you actually will contact them individually. You contact this object in Paris, you contact this object in Davis. And you need to be careful though, is that because they might be different. Therefore, for each of them, you might have to use a different interface. For the object in Paris, you might have to do method number 1. For the object in Davis, you might have to do method number 2. So there are different tedious because their locality, because their policy of that country. So essentially, you need to do different things to manage everything in your local server so you can actually pull this distributed computing together. So the idea of a shadow object is that, well, would that be convenient that I treat all the objects, they're all local to me. I just locally interact with them with a pretty uniform interface. And then as if all this distributed object around the world, maybe billions of them, it looks like it's actually on my grid in front of me, on my powerful server. So shadow object is a concept that how we can actually implement this kind of virtual access to all the objects. So essentially in the virtual object, in the shadow object, I have this kind of scenario that instead of directly access to the real object, I actually create a shadow object. So on the left top corner, this is called a shadow for this object. So what happened is that whenever I make a call, remember now this object is on my client, on my computer, on my mobile phone. So when I actually interact with this object, the interface will be exactly like this interface here. So whenever I make a call, say I want to get the I want to watch a movie as if I'm actually watching local, assuming I have a movie, is actually, say, whatever. What's the newest movie you guys are watching this day? Oh, I haven't watched that one. Yeah, I saw that. That was a fantastic movie. The last one probably made by. I only watched the Wikipedia, so I know the plot. I haven't watched the movie yet. It looks exciting. I don't want to be spoiler. I cannot say too much. Okay, so you want to watch this movie as if you are actually local on your smartphone, but actually the movie is actually stored in a server somewhere else. But when your player on your smartphone try to play the movie, it just interacts with that shadow as if the movie is local. And then the shadow object will make sure the communication mechanism will actually connect with this particular object here. So from your computation, everything is local, but shadow object help you provide a reference, provide the connection to the real one. Okay. Any question? So essentially, that shadow object come up with a few good good use. I mean, for example, I talk about this is good for distributed programming. This is provide an abstraction for a lot of remote sensing or other kind of resources. And also, because it's shadow, that you can actually dynamically changing it. So for example, the first time I call this shadow, it might be connect to this resource. But what happened is that the internet is down and performance is bad for that area, that you can actually redirect to different resources. And your local is totally transparent to those changes. So that's why shadow objects provide a lot of mobility and the tracking for those. Okay. All right, so I'm going to just show you an example about the shadow object. Now I want to go for here. I will skip the remote procedure call first, but tell you that this hierarchy. So you're familiar with this class hierarchy in remote. You're familiar with the class hierarchy. So now I kind of extend a little bit for homework assignment number 3. So you have a core, you have a person, you have a transaction, you have a fly, right? As I talked about that last time. So we have a class hierarchy looks like this, and that's the definition over here. And now I'm going to do something. 1 second. I'm actually make one function become virtual function. Get distance. So you probably already know that in the homework assignment number 2, I have something called get distance. Basically, I try to compute the distance between 2 locations. That's what the get distance is trying to do. So I actually make that get distance virtual. And let's see what I did here. I'm actually going to create another derived class called shadow fly. So it's a shadow object. I just name it as shadow. So now this is my new inheritance hierarchy or class hierarchy. So I have core to the transaction to the fly. And the fly, the derived class called shadow fly. And we have a virtual function called get distance. So if it's virtual function called get distance, then basically both shadow fly and fly has that virtual function. So now I'm going to play the magic for shadow object, why I'm actually doing this. So now let's go back to this picture. Let's go back to this picture. So let me tell you, this one is my fly. object. This is my fly object. Somewhere in maybe United Airlines database, they have a fly object. This one is actually shadow fly object. So the shadow fly object is actually on your mobile application. So you have a shadow fly, you have a fly. So essentially, remember what virtual function is. Virtual function is at the time the object was created, what's its class type. That will determine the behavior of that function called getDistance. Right? Remember, that's a definition of virtual function that we actually determine at the creation time. So what I'm going to do, when this object was created in United Airlines database, this is going to be created as class flight. And that object was created on your mobile phone. It's not going to be class type. It's going to be class shadow flight. So we actually have two objects. One is created this way, one is created that way. Okay, why is that? So let me actually tell you what shadow fly is doing. So shadow fly is not really doing the fly step. The shadow fly is actually being created to know the real object is here. So what's shadow? Shadow means that it's actually a shadow of some real object. So that shadow fly is just trying to find its way to access its real object. So essentially what we're doing is that from the application perspective, I don't know whether this object is local or remote. I don't know. I mean, maybe I'm running this program on a United Airlines server if I'm a United Airlines employee, but it could be I'm actually using my mobile phone on my application. So essentially, if I develop an application, I don't actually care whether I'm actually with this guy or I'm actually with that guy. But at the time created, is created as a shadow or as a derived class under virtual function, then the application just simply treat that as a fly. Because remember what's a virtual function? That one could be casting. The shadow fly could be casting as a fly on my computer. So when I call it, I just call a fly. If I'm lucky, I'm actually with this server here, then the call will actually directly come here. But if I'm on vacation and I'm install that on my mobile phone, then that will invoke the shadow fly version. And then that will redirect the call over here. And that's the application. Okay, I think I'm done here. Any question? Okay, again, if you have any question, I'll be outside.